Hello students, in this video you are going to learn about the molecular orbital theory, especially the formation of dinitrogen according to molecular orbital theory, and also we are going to calculate the bond order of dinitrogen. Let me explain step by step in this process, so follow me. The target is a nitrogen atom, another nitrogen atom, they are going to combine to form dinitrogen molecule. So this is an atom, this is an atom, this is a molecule, this is a target, but it has to follow a systematic scientific pattern. That is what you are going to learn in this video. So in the examination situation, I recommend you to start with a energy scale bar. So draw a energy scale bar that represent energy on the left side. Okay, this is the first step. The second step is write the electronic configuration of individual nitrogen atom. So in the case of dinitrogen, one nitrogen has 7 electron that can be represented as 1s2, 2s2, 2p3. Another nitrogen also has 7 electron that also can be represented as 1s2, 2s2, 2p3. Now what we are going to do is we are going to use atomic orbitals of each nitrogen and form a molecular orbital. Here the important relationship or important step in this process is called linear combination of atomic orbital. Linear combination of atomic orbitals. So let's start with an atomic orbital. We have to start with 1s2 and 1s2. So let me draw from the bottom that. So 1s of this nitrogen and 1s of this nitrogen. These two called atomic orbitals. These two called atomic orbitals. The atomic orbitals undergo linear combination that produces two molecular orbitals with different energy level. The one below the atomic orbital energy level is called a bonding molecular orbital that can be represented as sigma 1s, whereas the higher energy molecular orbital called anti-bonding molecular orbital, which is sigma star 1s. One s atomic orbital, another 1s atomic orbital. Similarly, next we can do for 2s orbital. So 2s of first hydrogen, 2s of second hydrogen. It can form two types of molecular orbital theory. Molecular orbitals, namely sigma 2s, sigma star 2s. Then we have 2p3. So 3 orbitals of this nitrogen and 3 orbitals of this nitrogen can be written like this. This 6 orbital going to form 6 molecular orbital. 3 of them are bonding molecular level. This is this, and 3 of them anti-bonding molecular level. Like this. Okay. So we know that this orbital represent 2px, 2py, and this is one is 2pz. Similarly, this is 2px, this is 2ps, 2py, and this is 2pz. So this is how we have to arrange the molecular orbital and atomic orbitals. So on the left we have atomic orbitals of the first nitrogen, and on the right we have atomic orbitals of the second nitrogen. In the middle, we have molecular orbitals. So the lower energy orbital called bonding molecular orbital. Let me write bonding molecular orbitals. And the higher energy bonding molecular higher energy orbitals called anti-bonding molecular orbital. Anti-bonding molecular orbital. Similarly, this is also a bonding molecular orbital. This is an anti-bonding molecular orbital. This is a bonding molecular orbital. This is also a bonding molecular orbital. This is a anti-bonding molecular orbital. This is also a anti-bonding molecular orbital. Let me name this. This is pi 2px and pi 2py. Here sigma 2pz. Sigma 2pz. Similarly, sigma star 2pz, pi star 2px, pi star 2py. So we have designated all the molecular orbitals corresponding to their bonding level and anti-bonding level. Now totally we have 14 electrons. This nitrogen has 7 electrons, this nitrogen has 7 electrons. Therefore total electron is 14. Let's fill the molecular orbital based on the Un's and other quantum mechanical rules. So in oneness we have a 2 electron in this orbital, 2 electron in this orbital. Therefore 4 electron can be filled in this way. So 2 electron occupies bonding molecular orbital of the sigma oneness and 2 electrons occupies anti-bonding molecular orbitals of sigma star oneness. Similarly 2s2, 2s2. So this orbital has 2 electron, this orbital has 2 electron. In total 4 electrons. So 2 electrons filled in the bonding molecular orbital level, whereas 2 electron can be filled in the anti-bonding molecular orbital level. Similarly, in the 2p case, we have 3 electrons. So each electron occupies in the 2px, 2py, 2pz. Similarly, 2px, 2py, 2pz. Totally, we have a 6 electron. We have to follow the Hund's rule and Pauling exclusion principle. According to the Hund's rule, first we have to fill the orbital in a singly filled way. Then you just pair up. Then another 2 electron occupies the sigma 2pz level. So because in total we have 6 electrons, so 2 plus 2 plus 2 equals to 4 plus 2 equal to 6. So 6 electrons have been already filled. So we don't have extra electron to fill the anti-bonding level of the 2p orbitals. So we completed the electron filling process. Now let's write electronic configuration of the dinitrogen. Electronic configuration of dinitrogen. So we'll start sigma 1s 2 electron, then anti-bonding level sigma star 1s 2 electron, then sigma 2s 2 electron, then anti-bonding level sigma star 2s 2 electron. Then if you look at the energy level of these pi 2px and pi 2py is the same. Therefore we can write pi 2px2 equals to pi 2py2. In the next case we have a sigma 2p is at 2. This is a electronic configuration of dinitrogen. Let's calculate bond order as per the given question. Bond order equals to NB minus NA by 2. Here, what is NB? Number of electrons in the bonding molecular orbital level. So this is a bonding molecular orbital and this is a bonding molecular orbital. the lower energy orbitals are called bonding molecular orbital. The higher energy molecular orbital called anti-bonding molecular orbital. So NB represents number of electrons present in the bonding molecular orbital. So bonding molecular orbital, bonding molecular orbital, bonding molecular orbital. Anti-bonding molecular orbital, anti-bonding molecular orbital, anti-bonding molecular orbital. So bonding, if you calculate the bonding molecular orbital electrons, 2 plus 2 4, 4 plus 2 4 plus 2 8, sorry 2 4 6 8 10. So totally we have a 10 minus anti-bonding level 2 4 4 by 2 equals to 3. Therefore the triple bond exists in between two nitrogen. This is a bond order. Next, calculate or predict the magnetic properties of the dinitrogen. Look at the bonding level and anti-bonding level molecular orbitals. If you find any unpaired electron present in the molecular orbital, either it can be bonding level or anti-bonding, that doesn't matter, but whatever any electron is present in unpaired way, then the molecule can be paramagnetic. But in this case now we have all the orbitals are paired up, so that means electrons are paired up. So therefore we don't have any no lone pair. Since no lone pair is present, since no unpaired electron is present, this nitrogen is diamagnetic. Diamagnetic means there should not be any unpaired electron. Since look at sigma 1s2 filled, sigma star 1s2 filled, sigma 2s filled, sigma star 2s filled, pi 2px filled, pi 2py filled, sigma 2pz filled, are all filled, which means paired. So there is no unpaired electron. Do not see the unpaired electron on the atomic level. You have to look only in the molecular level. Okay, that is what the bond order says. So here the electronic configuration and the bond order is very important, that you should know that, because this question definitely will come for the exam. Okay, so let me summarize how we have to start and how we have to calculate bond order and predict the magnetic property of the dinitrogen. First, write the electronic configuration. First, don't forget to write the energy scale on the left. First, write energy scale, write the electronic configuration of first nitrogen and electronic configuration of second nitrogen. These two orbitals undergo linear combination. Okay, in the case of valence bond theory, we used to say overlapping, but here we used the terminology called linear combination. Okay, on the left we have atomic orbitals of this hydrogen, on the right atomic orbitals of this nitrogen. In the middle we have a molecular orbital. Unlike atomic orbitals, in the atomic orbital, if you look, the energy levels are same, whereas the molecular orbital splits their energy. The lower energy molecular orbital called bonding molecular orbital, where the higher energy molecular orbital called anti-bonding molecular orbital. So like that you have to first draw the molecular orbitals. Then totally we have 14 electrons, 7 electrons from this nitrogen and 7 electrons from this nitrogen, totally 14 electrons. Therefore the 14 electron can be filled following the Hund's rule and Pauli exclusion principle. So first fill the lower energy level, followed by higher energy level, lower energy level, higher energy level, bonding molecular orbital and anti-bonding molecular orbital. But here we have totally in 6 electrons, so 6 electrons are filled. The electronic configuration can be written like this: sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, pi 2px2, pi 2py2, sigma 2pz2. That's it. Bond order can be calculated: number of electrons present in the bonding molecular orbital and minus number of electrons present in the anti-bonding molecular orbital divided by 2. So the value is now 3. Therefore triple bond exists between two nitrogen. Since there is no lone pair is found in any of this bonding molecular or anti-bonding molecular orbital, therefore the dinitrogen is an example of diamagnetic. So the magnetic properties of dinitrogen is diamagnetic. We have to also understand the other species. This molecular orbital diagram is not only for the dinitrogen. We have several examples. We will study in that subsequent video. Thank you very much.